So we are in Geometry, Module 2, Lesson 1, Explain 3, Specifying Translation Vectors. So you may be asked to specify a translation that carries a given figure onto another figure. You can do this by drawing the translation vector and then writing it in component form. So let's look at our example 3. So specify the component form of the vector that maps triangle ABC to triangle A prime B prime C prime. So we have our figure. And so what you'll notice is that in order to determine the components of our vector, we have to note two things. One, what is the horizontal change from the initial point to the terminal point? And we have to do the same thing for our vertical change from the initial point to the terminal point. And see how much just that has changed. So we pick one point because if they're all going to change by the same quantity, the vector is going to be the same regardless of the vertex that you move from. So you just pick one and it's ordered pair and go from there. So they picked B in this situation. And so they said, okay, well, originally I'm starting off at -4, 1, and I'm moving to 1, -3. So to go from -4 to 1, what you'll see is they subtracted the difference between them and said, well, to go basically from what do you have to do to 1 to get to -4 is you have to have a movement of 5 is what they are basically looking at. So again here on my y is 1, and on my terminal point, the y is -3. So what do you have to do to 1 to get -3? You have to -4. So thus our our vector in component form is 5, -4. So let's go ahead and look at the next page. From a vertex in triangle ABC to its image in triangle A prime B prime C prime. So again, it doesn't matter which one you pick. In this situation, they are picking A to A prime. And so when you do this, and yeah, initially you can just count up and count over to indicate it, but if you are given just the coordinates without the graph, this also wants to make sure you can do it using mathematics if need be, so you don't have to graph it to figure it out. So this is the math behind it. So we have our coordinate pair, 1, 2, 3, -3, up 1, and over 2, up 4. So 2, 4 is going to be what we're moving from in 2. So the question is what -2 -3 is going to give us our answer. So we're at -2 and we ended up at 2. So you're subtracting your initial point from your terminal point and you get 5. So again, we're going to subtract our initial point and our vertical change, or our y, from our terminal point of our A prime. And hopefully you got this. Thus giving us the vector in component form. Okay. So look that over, see how you did it, check your math, and we'll move on to our reflection. So what is the component form of a vector that translates figures horizontally? Explain. So what would that look like if we are translating something horizontally? What would the component form of the vector look like? So that would be that we have a comma 0. There's nothing happening to our vertical movements. It's all horizontal. Right? So with that, you can also think about, what if you just had a vertical shift? What would that look like if you were to write it in component form? All right, your turn. So in example 3a, suppose we had triangle A prime, B prime, C prime is the pre-image, and triangle ABC is the image after the translation. What is the component form of the translation vector in this case? How is the vector related to the vector you wrote in example 3a? So basically, it's shifting. We're switching them and moving the triangle back. What would that do to the component form of the vector? And that was from example 3a. So we have -5, 4. So the components are in the opposite of the components of the vectors before. So if last time I moved up 5 to get back to my original spot, I'd have to move down 5. If last time I moved to the left 4, then to move back, I'd have to move to the right 4. So that's an essential component of keeping in mind in terms of being able to move an image forward and backwards along that vector, is that the signs would change, because instead of going up, you're now going down, or instead of going right, you're now going left. But the quantity hasn't changed. You're still going by the same value. All right, next section we'll have elaborate. Hope this helped.